All right. Hope everyone is doing well. If you can please, if you can see IBM Watson update from wow to how to now, raise your hands if you would be. All right. We'll be getting started here right in a moment. Tonight we're going to be talking about artificial intelligence and GitHub and get our Watson robot programming next. The idea is to get you started and see what AI is, learn some GitHub, and then apply it towards Watson next week. All right. We're still waiting for some folks to get here and we'll get started. There's a particular video I'd like for you all to see, and that's why I want to do that. There. While you do that, when people get here, I'm just going to show. Waiting. I don't have any sound on, so as you're waiting here, you're thinking you see these robots. Watch this guy. So, there's a robotics class. If you haven't looked at Atlas lately, or you haven't looked at Boston Dynamics, they're really making some advancements on their robots. Things you can watch this. Mind you, it wasn't that long ago we were getting robots to walk up a set of steps. Which is pretty darn cool. And then they got, I'm looking for the one. Yeah, well, I'm not sure. We'll check this one. We're getting started here, folks, so I'm showing you. Boston Dynamics was bought by Google. We're going to get in artificial intelligence, but you're starting to see the robot, the hardware now combined, you can imagine, with some artificial intelligence. It's starting to get amazing. Look at that. So you could grab, this is a handle that you could take the robot on. This is picking up 100 pounds, Roger. Like this. So, let's see. Watch how fast this thing goes. Okay, that's not really as fast as this thing's going to get. Now it should start to pick up. Now it's galloping. Like, just like a horse, the legs are off the ground at one point. Look at that. Corrected itself. Think about the technical challenges of getting it to do that. There's another shot, which we're not going to spend a lot of time. It actually shows them breaking the speed record. This is the one I want. Not really. Oops. This looks like a horse rolling through. We don't have time. We're going to go ahead and stop at this. I wanted to get everybody a chance to log in today, and we'd had it there. But if you want, go to Boston Dynamics, known by Google. Very impressive new robotic changes. So if you need to do a paper on something, you want to try something interesting for school, this would be a great thing. I would recommend. We are going to go today something totally different now. We're not totally different. That's hardware. Now we're going to start talking about artificial intelligence that you need to run to make robots more useful and things. Many of you have all the components for IBM Watson that we did. We'll make those people. Let me ask, it was the Saturday people, the Thursday people that have lab on Thursday. You have not made a Watson robot, correct? Raise your hand if you've made a Watson robot. Anybody now? Just raise your hand if you raise. All right, Aiden, you're Saturday, correct? So the Saturday folks, yep, have done this. So this Thursday we have middle school, and you're going to build your robot. Make sure you bring your Raspberry Pi and the components we gave you. All right? So bring your stuff for Thursday. We're going to make your Watson robot. All right? Now, but let's get in there, and I'm going to show, this will be a little bit longer video than normally we do in this class, but it's a really well done video, and there's a lot of topics that we may go back through and then go into this. But we're going to explain what AI is currently doing right now, and then talk a little about Watson. Watson is just a different variation of AI. Everybody's going to be coming out with their own specialties of this. So here we go. That's how Watson works. We're going to go ahead and, let me see if I can get this to pop up. Okay, folks, I'm going to go ahead and run this. Yeah, Raspberry Pi, and then I gave you an LED and a microphone for your Raspberry Pi. Bring those. If you want to bring your Raspberry Pi, that's fine, but bring it for Thursday. All right, here we go.
IBM's Watson is at the forefront of a new era of computing, cognitive computing. It's a radically new kind of computing, very different from the programmable systems that preceded it, as different as those systems were from the tabulating machines of a century ago. Conventional computing solutions, based on mathematical principles that emanate from the 1940s, are programmed based on rules and logic intended to derive mathematically precise answers, often following a rigid decision tree approach. But with today's wealth of big data and the need for more complex, evidence-based decisions, such a rigid approach often breaks or fails to keep up with available information.
So what this is saying is, tabulation machines, that really honestly what gave a lot of these early computing companies their start, and gave IBM its start. They were able to do the census. Then went from physical, mechanical tabulating machines to computers we know of, but a very basic logic, if-then statements, the kind of things I've taught you. But while this has all been going on, we now are getting a ton more data, and it's really hard to get that off. All right, so I'm going to go ahead and let's keep going through here.
Cognitive computing enables people to create a profoundly new kind of value, finding answers and insights locked away in volumes of data. Whether we consider a doctor diagnosing a patient, a wealth manager advising a client on their retirement portfolio, or even a chef creating a new recipe, they need new approaches to put into context the volume of information they deal with on a daily basis in order to derive value from it. This process serves to enhance human expertise. Watson and its cognitive capabilities mirror some of the key cognitive elements of human expertise. Systems that reason about problems like a human does. When we as humans seek to understand something and to make a decision, we go through 4 key steps. First, we observe visible phenomena and bodies of evidence. Second, we draw on what we know to interpret what we're seeing, to generate hypotheses about what it means. Third, we evaluate which hypotheses are right or wrong. Finally, we decide, choosing the...
So what Watson does is this is how human beings think, and part of what's called cognitive computing, which Watson is part of, and you're going to see it as deep thinking, and there's reasons they're going to get these names. We'll go into more with the time we have today. But these things right here, decide is the last one. But go through on that again.
Second, we draw on what we know to
So we
interpret
observe,
what we're seeing,
we
to
interpret,
generate hypotheses about what it means. Third,
and then we evaluate, right? So imagine if you could repeat that over 10,000 times. And then every time you did it, you judged how correct you were. That's the core of what's going on with AI. We have lots and lots of data. Data is doubling every couple of years. Most of it's unstructured. So another big part of this is it's able to read the written word in the proper context. We'll get to all the challenges with that. Why is a house burning up ends up burning down, right? Your nose runs, your feet smell. Again, hard euphemisms, but we teach the computer to understand that. But if we do these 3 things, evaluate, then we make a decision. If we can do more observers, make a hypothesis, evaluate it, run it over and over again, using mathematical probabilities, we get there. Then we make a final decision. Well, that's very possible. That's part of machine learning.
Are right or wrong. Finally, we decide, choosing the option that seems best and acting accordingly. Just as humans become experts by going through the process of observation, evaluation, and decision-making, cognitive systems like Watson use similar processes to reason about the information they read. Watson can also do this at massive speed and scale. So how does Watson do it? Unlike conventional approaches to computing, which can only handle neatly organized structured data, such as what is stored in a database, Watson can understand unstructured data, which is 80% of data today, all of the information that is produced primarily by humans for other humans to consume. This includes everything from literature, articles, research reports, to blogs, posts, and tweets. While structured data is governed by well-defined fields that contain well-specified information, Watson relies on natural language, which is governed by rules of grammar, context, and culture. It's implicit, ambiguous, complex,
See
and
that?
challenging to process. While all human language is difficult to parse, certain idioms can be particularly challenging. In English, for instance, we can feel blue because it's raining cats and dogs, while we're filling in a form someone asked us to fill out. When it comes to text,
Think about that. We're filling in a form that someone has to fill out. So you're filling in, you're filling out. So that does make it a challenge for Watson in the beginning for all these learning systems. All right. Okay, so let's keep watching.
Watson doesn't just look for keyword matches or synonyms like a search engine. It actually reads.
So if your search engine, all you have to do is find the words. It's not really doing necessarily. And then, Google based it on what were the most popular searches, and they would move it up because they assume the wisdom of the group, wisdom of the tribe would select out that the most popular answer is probably going to be the right one, the consensus answer. This is a little bit different here now.
It interprets text like a person. It does this by breaking down a sentence grammatically, relationally, and structurally, discerning meaning from the semantics of the written material. Watson understands context. This is very different than simple speech recognition, which is how a computer translates human speech into a set of words. Watson tries to understand the real intent of the user's language and uses that understanding to possibly extract logical responses and draw inferences to potential answers through a broad array of linguistic models and algorithms. When Watson goes to work in a particular field, it learns the language, the jargon, and the mode of thought of that domain. Take the term cancer, for instance. There are many different types of cancer, and each type has different symptoms and treatments. However, those symptoms can also be associated with diseases other than cancer. Treatments can have side effects and affect people differently depending on many factors. Watson evaluates standard of care practices and thousands of pages of literature that capture the best science in the field. And from all of that, Watson identifies the therapies that offer the best choices for the doctor to consider in their treatment of the patient. With the guidance of human experts, Watson collects the knowledge required to have literacy in a particular domain, what's called a corpus of knowledge. Collecting a corpus starts with loading the relevant body of literature into Watson. Building the corpus also requires some human intervention to cull through the information and discard anything that is out of date, poorly regarded, or immaterial to the problem domain. We refer to this as curating the content. Next, the data is pre-processed by Watson, building indices and other metadata that make working with that content more efficient. This is known as ingestion. At this time,
all right. First, it curates all your data. It figures out what is relevant and what is not. And then they call it ingestion, but then it goes on and it organizes the data.
Watson may also create a knowledge graph to assist in answering more precise questions. Now that Watson has ingested the corpus, it needs to be trained by a human expert to learn how to interpret the information. To learn the best possible responses and acquire the ability to find patterns, Watson partners with experts who train it in using an approach called machine learning. An expert will upload training data into Watson in the form of question-answer pairs that serve as
So, you learn about France. They just start uploading all these pairs in the Watson. All right? This helps Watson better understand everything in its contents. It's got all these questions. All right? Otherwise, if you like, just catch up what we're doing here. We're learning about Watson. I'll make sure you get it. All right.
Truth. This doesn't give Watson explicit answers for every question it will receive, but rather teaches it the linguistic patterns of meaning in the domain. Once Watson has been trained on QA pairs, it continues to learn through ongoing interaction. Interactions between users and Watson are periodically reviewed by experts and fed back into the system to...
Again, it's just reiterating. It's getting more questions, doing it probably at incredible speeds.
Help Watson better interpret information. Likewise, as new information is published, Watson is updated so that it's constantly adapting to shifts in knowledge and linguistic interpretation in any given field. Watson is now ready to respond to questions about highly complex situations and quickly provide a range of potential responses and recommendations that are backed by evidence. It's also prepared to identify new insights or patterns locked away in information. From metallurgists looking for new alloys to researchers looking to develop more effective drugs, human experts are using Watson to uncover new possibilities in data and make better evidence-based decisions. Across all of these different applications, there is a common approach that Watson follows. After identifying parts of speech in a question or inquiry, it generates hypotheses. Watson then looks at evidence to support or refute the hypotheses. It scores each passage based on statistical modeling for each piece of evidence, known as weighted evidence scores. Watson estimates its confidence based on how high the response is rated.
This is what I want you to get. This is what a computer starts doing. It stores, as it evaluates things, it starts rating how likely what I'm thinking is true. The computer starts doing that. And then it's able to make decisions with a certain level of certainty. And it warns you. And as it learns more, you want that, the decision tree to get up to 92%. Clearly, 6 or 31% is not real helpful.
During evidence scoring and ranking. In essence, Watson is able to run analytics against a body of data to glean insights, which Watson can turn into inspirations, allowing human experts to.
So as it's gaining these things, I'm 92% certain of this, 82% certain of this. It can take all those insights, ignore down here so you'll learn something new.
To make better and more informed decisions. Across an organization, Watson scales and democratizes expertise by surfacing accurate responses and answers to an inquiry or question. Watson also accelerates expertise by surfacing a set of possibilities from a large body of data, saving valuable time. Today, Watson is revolutionizing the way we make decisions, become experts, and share expertise in fields as diverse as law, medicine, and even cooking. Further, Watson is discovering and offering answers and patterns we hadn't known existed faster than any person or group of people ever could, in ways that make a material difference every day. Most important of all, Watson learns, adapts, and keeps getting smarter. It actually gains value with age by learning from its interactions with us and from its own successes and failures, just like we do. So, now that you know how it works, how do these ideas inspire how you work? How can Watson make you a better expert? What will you do with Watson?
All right. They now have Watson out there. They've given APIs. Remember, APIs are a way for my software to hook into your software. And they're making those more and more available. But let's go a little deeper dive for what we're talking about here. All right. We could have a year-long course on artificial intelligence, folks. So we can only do so much. Let's do this. So I'm going to go pull up this PDF right here. All right. Again, this is developed by, and again, this is developed by IBM. So we're going to tell you how great their system is. Clearly, Apple has theirs. Think of it with the voice software. Amazon has it with Alexa. Apple has it with Siri. Everybody's got different ways of doing this. But let's talk about Watson because that's what you're going to get access to. All right, and there's a hand up here. Let me put it down. Somebody have a question with their hand up? Or that was for something else. All right, let's go ahead. So, brief history about Watson. And, you were a kid when this started. It was a research project back in 2006. It's a demonstration in Jeopardy. This is the software, the AI learning that won on Jeopardy. And so now they're using it with healthcare still today. Their goal is to pass, I think they passed it, Watson for healthcare. They took the test all doctors take before you can be a doctor. They passed. Is now working on financial services, and now they're letting you write in this so you can use the cloud. So we can talk about how that happened. All right. You got mobile. You got big data, which we've all heard about in the cloud, Internet of Things. This is all happening at once. So literally, this kind of AI was impossible before you were born. It really wasn't really available until you were probably just a few years old. All right, so for some of you, you're older than Watson and this kind of AI. When I say Watson, I'm talking about this kind of, we're going to talk about different types of AI in a minute, okay? So here, they're going to talk about business, which is true. 90% of the world's data was created last 2 years. And this is going to happen every 2 years. 80% of the world's data is unstructured. What we mean by unstructured is structured, think like a zip code, street address. If I put that in a spreadsheet and I have zip code, I have street, I have city name, that's all structured data. And honestly, that's pretty easy to use, but most of the world is not. It's in the written world, which is not structured. All right? If you got all this data, they're arguing you're only using about 20%. All right? And they're saying, that's. All right. So here's some of the things that you have that they talked about. It understands natural language. That's why we have the mic, by the way. So you can experiment this after this class is over. For any of you that really start getting into this, I will tell you the career is going to be wide open in this. AI struggled for years, but what it was is the concepts were there, but we didn't have the ability to do it. We'll get into neural deep layers in a minute, hopefully. All right, so what it does is we now have with this bit of technology, big, computing power and the cloud, a bunch of server farmers that can do this, social media feeding in more data, everybody having mobile phone computers with them, social media, so now we can feed into this big data. We have a place to store it. We have even things connected to the internet. That's giving you tons of information. And our computers are fast enough to handle it. Well, that information is in human language, so Watson uses human language. All right, it then evaluates a question. Should I expect to see a fish swim? No, I'm 85% certain of that. And it goes on, right? Well, not fish swim, fish fly, I'm sorry. And then based on responses, it keeps improving. It keeps teaching itself. All right. All right. And this is some of the things they're claiming. I'm going to show you in a minute on some other AI notes to see how fast this is all spreading. There's 6 instances of Watson deployed in the last 12 months. This is in 2012. 90% of the nurses followed Watson's recommendations. They said that 75% nurses follow Watson's recommendations. Think about that. They're getting more market to time with cancer therapies. All right? So, give you an idea. For medicine, they have 605 pieces of evidence, 2 million pages of text, 25,000 training classes, 14,000 clinical hours. That's all in the computer. That's what the computer's looking at. And the Watson, they're saying smaller and faster. The one that won in Jeopardy was almost the size of the room. Now, the newest one is something like 100 pounds. Still bigger than your PC, but not by a lot. Okay? So, and then, that's as they're just pushing their products here, but it's used by, therapy designers, so research, diagnosis, advisors. Well, we can base our decisions on real data and we know it's true. All right. All right. And, okay. So they said this earlier, so I'm just bringing it out right now. Tabulating got where IBM got its start. Then you had the programmable era, and then you now cognitive. And this is going to get our next part of this. We're getting computers to think more like you do. Now, it's not going to even get close to what you can do yet for you. So you're not going to have a robot wiping you out. But it can do that. All right. Hang on 1 second. And it was that. All right. Finish. No. Okay, it's finishing up. All right. they did this. We won't go into this one here. So I'm going to go back here. Oops, sorry about that. I don't want to do that. Stop.
IBM's Watson is at the forefront.
Sorry about that, folks. Let me go back to my down here. Now, we're going to get into some. First, does anybody have any questions about Watson? We're going to learn about deep learning, which is kind of what Watson's doing. We're going to talk about the difference between AI, machine learning, and deep learning right now. That's really what I want to get you in here. Any questions? All right. Now, all right. This is by NVIDIA. And they are very much into, we know NVIDIA for making video cards, but Watson was on text. This is on visualization. So they were real good about saying, is that a rabbit or the face, or is that someone wearing a hat? And getting the computer to be able to see that. So we're going to, again, last one was IBM. That's been Watson. Here's NVIDIA.
It all begins from a single origin, a unique point in space and time. This is the spark of innovation that fuels your most amazing breakthroughs. It's a passion for discovery that unveiled the genesis of all that exists in the universe. Today, the power of AI helps computers achieve superhuman capabilities in image recognition.
And that's their special.
Scientists save our most precious resources by analyzing in 1 month what used to take 10 years.
是谁发明了机械计算机？
Everyday devices translate even the most complex languages from voice into text and images into words.
Xavier is now present.
Helping the visually impaired recognize an old friend, or letting a blind woman read to her child for the first time. Autonomous vehicles give us the freedom to reimagine our city streets and travel where there are no streets at all to help the lost find their way home.
Oh, by the way, it was just in Wired Magazine today. AI drones are now racing with human drones. They're a little more cautious than human drone drivers are. You can expect they'll tighten that up, and they will be beating human drivers on the drones. It might be creeping everybody out how fast these things are going on.
We see robots teach themselves to perform simple tasks. We even watch in awe as they take their first steps. And today, a 2,500-year-old game meets its match as a computer competes with one of the greatest human champions of all time and wins. This is the collective imagination, fueled by forward-looking technologies and the beginning of your most amazing discoveries yet to come.
All right, so again, I want to just we'll get back to that in a minute. Deep neural, we may come back to that. Honestly, I don't think we will, because we can use this. All right, so let's go back. All right, now I bring out this next trend because if you talk to a family member that's been in computer science, if you have a family member that's in computer science, they're going to say, well, we've heard about AI all my life, and it really never got very far. Yes, in the beginning, we got computers that could play chess and checkers, but that was brute strength. That was brute, if this is true, do this. If these things, it was just brute computing power, and you were trying all your options. All right? But lately, machine learning, and we're going to get to deep learning, has really taken off. There was some in 2000, it's dropped down that and then started really ricocheting back up here. And deep learning as a version is I would say, the leading edge of machine learning right now. So think of that. And Watson uses some of this too. All right? Just to give you an idea, in the last 4 years, think about it, 4 years. Some of you when you were 10, 9 years old, we've gone from just 50 publications to 350. Those are all ways that's of you telling you that people are getting into it big time. That's exponential growth. All right? And number of conferences and workshops over the last 10 years. You can see in the last year alone, look how many more in 2016 there were than the years before. It's really exploding now. Okay? And people at Google think so. They're using it here. And we're going to get to these deep neural networks here and what we really mean by that. Okay? So, this is the number of projects Google did in 2012 that had AI, that you would call deep learning AI. And we're going to get that in a minute, what that is. Now look at 2015, they have 2,700. Went from less than 100 to 2,700 in 3 and 4 years. Even for technology in Google, that's pretty fast. And not surprisingly, a lot more investment in it. Okay? Here's all the industries wanting to try that. And again, Intiva's pushing it because that's their card for it. And they're going to talk about visual. So you're going to see this input. We'll get to it. But it's still a good, I like this description on this as I've been doing a lot of reading on this lately. All right? Now, so you have your input, which we've learned, Internet of Everything, cows that have sensors to tell you their temperature, weather stations everywhere, ways of measuring. We are now building sensors that are the grain of sand that we just spread out. And they're just going to give us information until they run out of energy. Then we'll go out and get new ones. Probably not a great idea for the environment, but that's what we're doing. All right, so talk about what artificial intelligence, machine intelligence that equals a human intelligence efficiency at a specific task. So think about playing chess and checkers. Artificial general intelligence, that's the ability to apply intelligence to any problem, not just specific. That's human level. So think about it. We just saw that thing in France. You want to become an expert in France. So artificial general intelligence, you feed it a bunch of information, it can become an expert on France. Good enough to compete with any French historian, Now, the one that scares everyone is artificial superintelligence, and that's much smarter than human brain and practically ever felt. We're not there yet. All right, folks. Creative people are still way ahead. But specific intelligence and general intelligence, we're getting it. i.e. pharmacy is a challenge, I think. All right. Yeah, and it's not even there, Really, over time, we're going to get there. I don't want to. All right, so now, machine learning is a type of artificial intelligence that provides computers' ability to learn without being explicitly programmed. That's the thing. There's no programmer anticipating every possible. Say if then, let's just say we did lights. If this color is green, then respond, go. If this color is red, respond, stop. If this color is yellow, respond, travel cautiously. That's doable. But remember, we just said most data isn't nicely organized. It's just not. And therefore, that won't work. You as a programmer don't have enough time to figure out every possibility if you're really going to do some deep things. Also, if you as a programmer write code, you usually have to understand the problem and the solution. This gives away that you may not all know it. So let's talk about what we're going to be looking at. So you have labeled data, then you have data, and you've got a machine learning program. So you tell the data, you sell it to machine. Once you've got labeled data, data that's organized, and you teach it, then you can start giving it just raw data. Based on what it learned in that algorithm, it can start to make prediction. And there's several different ways to do that. All right. And again, if you got a question, folks, raise your hand. In fact, just do that right now, because I don't know how my pacing is for you guys right now. How's the pacing? %73 voted. 82% voted. 5, 4, 3, 2, 1. Closing the poll. Sharing results. 9% of you saying my pacing's fine. Sorry for those slow. I'd rather be a little bit. I'd rather than not be too fast. Doesn't make sense. This gets very complicated quickly. All right. So again, here's the loading punch. Label training set. Email spam detector with a training set of already labeled emails. So your spam says, hey, if I see something about a Nigerian prince or somebody wants my checking account, it's going to probably drop it in spam. What gets interesting is when you can write code that it starts looking for patterns. All right? And then so you might have a spam that says anybody from this area, I gotta be careful here because clearly you don't want it. But anybody from this company that we found out is not a real company. It's a bot. It's not a real company, and it's used to do bad things with the computer. You can tell that, hey, spam it. Unsupervised learning says, I've seen enough scams that I start to, as a computer program, pick up that this is most likely a scam. And I can test it, and if I'm more than 60% certain, well, then I'm going to do it. So it just starts picking up and learning what does it, and it saves it. And then, example, reinforcement learning. You just keep running it over and over again, and you tell if it's right or wrong, so it learns better and better. All right? And so you can do all kinds of things here. This is, so anatomy is unsupervised learning. Supervised learning is like, you do regression analysis. And you'll get in that when you have some stats, so don't worry about that. Classification. Remember, we did the training. We have the text, we teach it. IBM's Watson, really good at reading text. So that's where his strong point is. And so then it can use wiki and clusterize data that isn't necessarily in a nice organized manner, right? Okay, so simple way to think about supervised learning. A picture, are there human faces? 0, 1, yes or no? Loan application, will they repay the loan? Yes or no? Ad plus user information, we'll click on the ad or not. That's a 0, 1, we can check right on it. Transcript and audio clip, like if you hear the audio clip, does it give it back? English sentence, can you give me a French sentence? That's language training. Sensors from a hard disk, plain engine. Is this thing about to fail up? That's why, and this is already out there. There's some of the heating and air units that you buy, your parents will literally, they'll call the maintenance people and say, go out to your air conditioner, it's going to go. And that would be really useful because most of the time we don't call on the heating or air until we stress it, i.e. it's really cold outside and your heating and air goes down, or it's really, really warm outside and your air conditioner's off, right? And in car camera sensors, we see that self-driving cars. But this is supervised learning. You're tagging it. This is not, it's not learning the rules yet. All right? Now, this is comparison. And these are all, this is just these different methods for doing it. We don't have the time or the technical ability to explain each one. But you can kind of say, hey, you compare it. Is this information close to the other one? You might use it for that. A decision tree. All right. SVMI knows no one. All right. All right. What is deep learning? It's part of machine learning. So if you have AI and then you have machine learning, then you have deep learning. All right. And Watson falls into this deep learning side. It's the new leading edge. Okay. And it's using neural networks, much like our brain does. We're going to get to that in a minute. We'll go back and look at that Google slide we saw earlier in here. It provides, the system uses tons of information, begins to understand and responds in useful ways. All right. And in fact, I'll make sure and upload. Can I upload this? Hang on a second. Before we leave, I'll give you, for folks that would like this presentation. All right. All right. Now, in your brain, and this is where they were trying to model humans, and since the 50s, but the computers couldn't do it. And so people that were in AI there weren't that many, and they just said, we don't have the computing power to do what we'd like. Well, like we just said, because of the cloud, because of computers you carry on your hands everywhere you go, we now can do this. So when your brain gets hit, all right, you have a hierarchy of neurons. Your brain collects it right off the top. We're not going to worry about how it's doing, but as it goes in deeper into your brain, you take all this visual simulation, and you can convert it into a face of a person or a dog. And then knowing that it's a dog and not your brother's face, you say, you call your dog by the name. So it layers down. There's a whole sense of neurons. They build upon each other, all right? And in deep learning, it's the same idea. So here's a deep neural network consists of a hierarchy of layers, where each layer transfers the input data into more abstract things. So takes that cat, starts translating everything till it becomes abstract. That's a cat. So let me show you where, back up here. Let me see where right here. Deep neural network. What it's doing is, this is a little bit of information in the beginning, and it keeps processing all the way down. What's it processing? It's asking a hypothesis as a question, and then deciding how certain it is about the answer. And then as it goes through there, at each stage it's sharing it across the network and asking specific questions across that network. That ultimately gets down to here and says, that's a picture of a frog. All right. And again, if you have a question, stop me and we'll try our best to go ahead and get it. All right. So now, and this is based on how our brain works. So here's the edges. Here's our nose and eyes. There's a face. Now tell me what the face is. Right? Now, deep learning idea is, all right, so here's why it works better. Input data, traditional learning algorithm, you would have to engineer features. You're anticipating what the questions might be as you're trying to teach this thing. Deep learning is more of a learn by itself. So what things we use it with, or what's required for it, you have speech or audio processing, computer vision, natural language processing. I would say computer vision is more NVIDIA, Watson, natural language. All right. And it's funny. You can tell these companies when they do these things, they focus on what they're good at. So here's a perception, computer starting to perceive things, because that's what NVIDIA does, right? And then neural networks for handwritten recognition, that was 1998. So it could start to recognize, hey, handwriting. And then remember I told you these are different techniques for deep learning, 1995, 2006, 2012. Google Brain Project, 16,000 cores. I've been working on that. Sliced up a cat's brain and basically wanted to process a computer, put as many neurons in that computer, transistors, as in a cat's brain. Can we get this as smart? And let's go on here. That doesn't really do a lot for me. Here's human performance for looking at images and getting it right or wrong. We are now closer, the lower this, the better, all right? Now, Google and computers can classify images better than we can. All right? All right. Here's word error rate and performance when you hear audio and speak recognition. Here's human performance. We catch, we do pretty well. Yeah, here's the error rate. The error rate's been dropping, and this is where humans are. This is getting close to that. So what that means is human performance is still better than a computer hearing audio, but we're closing in on that rapidly. Wouldn't surprise me if we're not already seated. So, but like we talked about, it involves big data, computation, and then a method of writing code so you take care of it. Here are all the players in this field. It's huge. IBM, NVIDIA, Facebook, Google. And here's all the startups. So we're going to go this, I'm going to show you this. This gets very in-depth and amazing. This is if you're a software person, AI may be the way to go. But say you have the input layer, that's the outer side of your brain, right? Then, and you might process. This does additional processing in each layer to get that final outlet layer. So each layer represents a series of neurons and progressively extracts higher and higher level features. And then it finally puts it all together. So this just sees a blurs of things. This begins to see the eyes and the noses, and I know it's a cat, right? So let me go up here. Let me show you what I'm talking about. The computer vision, right? As it processes through, by the end, it can take something abstract, this cat, and make it abstract like a word cat, or you make it a face. And just like, we don't have to read this, just like that, there's a neuron. We do that. The computer's doing that. And we're not going to get quite more than that right now. So, Thursday, we have lab. Saturday, we do not. It's a little bit weirded out because the Thursdays got kicked back. Saturday is the high school lab. But so for middle schoolers, understand this. If you come on Thursday, you have lab now. If you come on Saturday, it's a week from Saturday. Okay? It'll be December 9th, I think it is. So you do, if you're Saturday lab person, come, but not this Saturday, next Saturday. If you're a Thursday night person, come this Thursday. Also, bring your Raspberry Pi and bring your mic for this Thursday in particular. All right? And you can just see, you can look at all the stuff you start getting into. It gets really pretty amazing, actually. Okay, any questions? All right. I guarantee you AI at Amazon is pricing this stuff for our sales that's going on right now on Cyber Monday, whatever shopping thing. All right. So if there's no questions, I'm going to go ahead and stop here. And I hope you all have a great evening, okay? All right, then, everybody. Have a good evening now. Bye-bye.